This is the 8th and final video in the Fluent validation series. And in this video, it's soapbox time. That's right. I am going to climb up on top of my teeny tiny little soapbox and offer you some analysis and opinion and wrap up on this whole topic of validations. So I'd like to start off by revisiting our loan system rules. And what I think you may have noticed is we really haven't implemented them all. We've done a pretty good job covering rules 1 through 8, though I have to say I'm not totally thrilled with our treatment of rule 2. But we have not done anything about rules 9 and 10. So that's kind of a problem. Let's go back and look at our architecture diagram. Now, we could, as I mentioned early on, we could modify the loan add stored procedure and add some logic to it. And that way, those rules would be implemented here at the SQL database. But again, we talked about the disadvantages of doing that really it locks you into this one platform, and it just is a little bit more modern and flexible to have those kinds of rules implemented here in the DLL. But I think you'll see that there really isn't a Fluent validation way of doing that. I don't think I can come up with a rule using this Fluent validation rule syntax that really implements these concepts. And the reason is that the validator needs access to other information. For example, it needs access to the customer record, and it needs access to all of that customer's loan records. And really, at this point in the code where the loan has come in, you just don't have the data. So there is no way for a validator, without querying for more data, to make this decision. So what do? Well, I've gone ahead and I've implemented what I think is the proper way to handle these kinds of complex business rules. And I've written a function here called validate possible loan. And it uses a little bit of SQL. So the first thing I did was I created a stored procedure called get customer summary, where you pass in a social security number, and it passes back the SSN, the approval flag, and using a correlated subquery, the total amount of loans that this person has so far. So the code here opens a SQL connection, and it runs that stored procedure for the passed in social security number, and then it checks and reads out the results. So if it's able to access a row, it reads out the approval flag and the total loans. And then it applies rule 9. So if this customer is not approved, let's throw an exception. Similarly, if their total existing loans plus the new loan amount is going to exceed $5,000, that's rule 10, and we'll throw an exception there. There's also this little trailer, which is that if we didn't even get a record, that means that the social security number doesn't even match a customer. And that's kind of a variation on rule 9, that this isn't even a customer. So let's go ahead and control F5. I've switched us back to the CLI, and I just want you to watch this in action. So let's go ahead and let's select 3 to make a loan. And we'll put in a bad social security number and a loan amount of $100. And it says now unable to make loan. Bad is not a valid customer social security number. So that's hitting this line of code. So now let's go ahead and try to make another loan. And we're going to set the social security number to this individual. And we're going to send them $100. And it says unable to make loan. Customer with that social is not approved. And so we just bumped into that rule. And last, we'll do one more. 3 to make a loan. We can use 111223333, who is approved. And let's give them $4,800. And it says unable to make a loan. That customer already has $451.09 in loans, and this loan would put them over the $5,000 limit. So there you go. We are now enforcing all 10 of our rules. So this is where I get to climb up on my soapbox a little bit and analyze this. So where should you do your validations? I want to argue that doing a little bit of validation in the storage level, if you're using a SQL database that allows for things like foreign key constraints and check constraints and unique constraints, those are really useful. And this is just a base level of security. I encourage you to do it, but you can't rely on it because not all platforms enforce that kind of logic. And not every system is going to have the same kind of backend. You might want to switch and you don't want to be railroaded in there. So it's good to use it if you can, but it is not the primary route of validation. Your main place where you want to do your validation is in a library like this. And really, I think you've got two techniques. For simple validations that we've done, like pattern matching and checking lengths and checking for required fields, for things where the DTO that comes in, the data you have is sufficient, I really love the Fluent validation library as an elegant, very literate way of writing those rules. And then for complicated business rules, which are relational, which require that you pull information from various sources, well, I don't think there's any substitute really that I can think of for just writing validation code. That's what we're for. That's why we have this language, is to take complex business rules and articulate them in code. So there's nothing wrong with doing that. That's what writing a good application is for. Now, it may be that you will need to put some of this stuff in a controller, but if you can avoid it and you have a library, I really encourage you to just let the library take care of the business logic and let your controllers just handle the HTTP plumbing. So the very last thing you might ask is, well, what about the user interface? Shouldn't we validate there? And the answer is yes, of course. It's a little bit out of scope for this series, but if you're building, let's say that this loansystem.com is built in Angular or React or Vue.js or ASP.NET, there are a lot of ways that in that user interface, you can guide the user's data entry. So for example, on that social security number field, you can use an input mask to guarantee that they really have to enter 3 digits, 2 digits, and 4 digits. And you can do things like don't even enable the save button until all the required fields are filled in. Or if it's a name field, you can, on that input, you can trim it to 100 characters. So there are ways in the user interface that you can just really prevent the garbage from going in right at the beginning. And that's a great user experience because they get feedback right away without ever having to click the save button and wait for the database to kind of give them a result. So you can't validate everything that way, but of course, it's a really good idea. It makes for a very user-friendly app to put those UI level validations. So there you go. I think I'm done with my soapbox. We've done a really good job of covering a lot of different aspects of validation. I hope it was helpful and that you enjoyed it. Please like the videos. Please share the videos. Subscribe to my channel if you haven't. And also, if you have questions or corrections or comments, please send them to me. I love your feedback. And again, thank you very much for watching.